So good morning everyone. In the last class we have discussed exercise 12.3 where we have done the questions of putting the value of variable and finding the value of expression. So I hope every question is clear to everyone. Now the next topic is using algebraic expressions, formulas and rules. So now we'll try to use some expressions. So could you please repeat what you said about the activity? Kritika, soon after the class, I will try to explain again. Okay. Don't worry, I'm giving you some people some time to understand the activity and then only we will do. Now, what is this? They are telling the perimeter formulas. Okay. The perimeter of an equilateral triangle is 3L. Okay. This too we all know. What is perimeter class? Anyone? What do you mean by perimeter of a figure? Okay, Rishi, I will give. First, tell me what do you mean by perimeter? Yes, it is actually the length of boundary. So, in a triangle which is equilateral, we all know all sides are equal. Class, we can say in an equilateral triangle, all sides are equal. So, if one side length is L, second is also L, third is also L. So, the perimeter is given by L plus L, that is length of all the sides, and we have understood this thing that L plus L is same as 3L. So from this we obtained a formula. This thing we have learned in this chapter, how to add these terms, because these are like terms, we can add them. And you can see by adding we got a easy formula, 3 into side. So whatever side given to you, just put the value of that side in the place of L, you will get the answer. Suppose I say I have a equilateral triangle of side 15 centimeter each. Tell me the perimeter. What will you do? Will you go for 15 plus 15 plus 15, or will you go for 3 into 15? Which is easier for you? Easier is 15 into 3. The answer is 45. Yes, the perimeter is the length of outline of a shape. Very good. Now, similar is the case with square. In the square, there are four equal sides. So the perimeter becomes 4 into L. In the case of pentagon, which is regular, class, try to observe this name, this word, regular. Anyone having idea? What do we mean by regular pentagon? Anyone? What do we mean by regular pentagon? Okay, regular means equal or all sides equal. So this regular pentagon means all the sides of the pentagon are equal, or you can say all are L only in this case. If it is given only pentagon, you can't take it as equal all the sides. But if it is a regular pentagon, you can say all the sides are equal. Now, yes, non pentagon on the pentagon sides are equal. Yes. Yes, beta. This is a regular pentagon. Now comes the next topic, that is area formula. How this is obtained? Again, same thing. We all know area is actually the multiplication of dimensions. So if you have a rectangle, you have studied that if you have a rectangle of length L and breadth B, what is the area? Please tell. What is the area? Length into breadth. And we all know square is a special case of rectangle. Square is a special case of rectangle in which length is equal to breadth. So regular means equal sides that can be or any polygon. Yes, beta. Regular means all sides are equal. So class, if we take a square in that L and B are equal, so we can say area is given by L square. Any problem in this one? Please tell. Can we say area of a square is side square? Can we say this thing? Class, please confirm. Okay, we can say the area of square is side square. Good. Similarly, we have done this one L into B. Then comes area of a triangle. Yes, we can say. Okay. Then comes area of a triangle. We all know if this is a rectangle, whose area is L into B, triangle is half of it. So we can say area of triangle is actually half of, okay, Mokshita, I hope you understood area of square is L square or side square. I hope you understood this one because you have studied in a square, all sides are equal and the area is given by side into side. This one is clear. Then we have a rectangle whose area is length into breadth. The third one is area of a triangle. We have studied area of a triangle is given by like this. Suppose this is a triangle. We have studied this thing. If we have a triangle ABC and the height is H, base is B, we can say area of triangle is given by half into base into height. I hope this formula you all have studied about area of triangle. Okay. After this, they are discussing, sir, in perimeter and area chapter, we'll study the area of triangle perimeter. Okay. Yes. In that chapter of mensuration, we will study all these things again. Okay. Okay, Lavya, don't worry. Whatever formulas are left by you before, that all will be covered in the chapter mensuration again. Okay. Now, now we will try to understand the patterns, how these formulas are being made. Okay. Let's see. Okay. Hmm. Which pattern should I give you? Let me take the examples. Okay. 5 plus 9. Okay. Which example should be taken? 3, 5, 7, 9. 4, 7, 10, 13. Okay. Class, suppose you have pattern 4, 7, 10, 13. Can you tell me what is the pattern? If you have a numbers, if you have 4 numbers in series, can you tell me the pattern or tell me the fifth term in this one? So what we are doing is we are adding 3. Okay. So you can say the pattern is simple. Add 3 in the term and you will get the next term 16, then this one, like this you are going. Okay, very good. Can we give a general formula also? Class, can I give a formula for this? Suppose I want to ask the 10th term. Will you find all the terms to find the 10th term? Suppose I ask find the 20th term. How will you find that? You need to find a formula for that. Class, do you agree with me? Okay, tell me, can you make any relation? Can you make any formula of this? I know you can go step by step by adding 3 and find all the numbers. Okay, Lavya is saying 2n plus 1. Others, please try and tell me what should be the relation. What should be the relation? Lavya is saying the formula should be 2n plus 1 where n is natural numbers. Class, please tell me, is the formula given by Lavya correct? Is the formula given by Lavya correct or not? Okay, okay, very good. If two terms will add 6 and similar, we can do that. Okay. Class, try to understand. We will observe one by one. Can I write? Can I write this 4 as 3 into 1 plus 1? Please tell. Can I write this 4 as 3 into 1 plus 1? Is it correct? So everyone is agreeing with me. Now what about 7? Can I write this 7 as 3 into 2 plus 1? Yeah, I can write like this. So you can see I am trying to write the given numbers in a particular way so that I can write all the numbers in same way. Can I write this 10 as, class? What should I write like this? Please tell. 3 into 3 into 3 plus 1. What about 10? What about 13? 3 into 4 plus 1. Are you observing what is happening, class? Are you observing what is happening? This 3 and this 1 is same to same. Nothing is being changed. It is constant in all the terms. Only thing which is changing is this part. Can you observe this thing, class? Can you observe this? So, if I want to write the nth term, so you can say this was the first term, this was the second term, this was the third term, this is the fourth term. What about 20th term, which I was asking? Class, please tell me the 20th term will be how much? Now it is very easy for us. It is 3 into 20 plus 1. That is 61. So you can see how easy it becomes if we try to generalize it. This is known as generalizing, making a formula in which you just put the value and get the answer. Yes, Lavya, your formula was wrong, but it was very good that you were the only one to reach some way near the main answer. Apart from you, no answer came. So I consider it very good from your side. Okay. At least you tried to get that expression. I hope everyone found this. But Lavya's answer is wrong. Lavya's answer is wrong because he got 2n plus 1 and you can check that will not work. I think 2n minus 1, 4n minus 1. 4th is a 12, 16. No, it will not work. Only this will work. Fine. 3n plus 1 will work. Okay. Now let's take another relation. You all will help me in that. Suppose we take this only. I think this we have taken now. 3, 5. No, this is not done. Let's take this one. 3, 5, 7, 9. The relation is 3, 5, 7, 9. Tell me what is the next term? Yes, you are saying it is 11. So you that's mean you are saying it is plus 2, plus 2, plus 2, and plus 2. Fine. So now can you generalize this, class? Can you find a pattern in this? Can you find a formula, a general formula in terms of variable? Okay, Karnik is saying 2n plus 1. Fine. Others, please try. By Karnik has given the answer as 2n plus 1. Others, Tushita, I think, is saying the same answer, 2n plus 1. Kritika is saying the same answer. Ekta is giving the same answer. Fine. Very good. So that means we can check now. Let us try to check. Can I write this 3 as 2 into 1 plus 1? Yeah, I can write like that. Similarly, I have to check for the next 3, 4 terms. Don't give the answer from one term only. Try to observe the 4 terms so that you are clear about the formula. The next one is 2 into 2 plus 1. Then you have 2 into 3 plus 1. It is very well working in the formula. So you can see 2 is same, 1 is same in all the terms. Only this is changing, which is your natural numbers. Yes, sir, we should do that also. Yes, so we can say it. The formula, general formula is 2n plus 1. This is the general formula for this given expression, you put the value of n and you will get the answer. Mokshita, we all know the thing which is changing is this only 1, 2, 3, and so on. That is why I was able to understand that I can make this variable. We all know the thing which is changing is the variable. The things which are same forever are the constants. That is why I have made the formula as 2n plus 1, in which this n is the variable which was changing. Mokshita, I hope you are able to understand this thing, that in all the terms 2 and 1 was same. Yes, with which we are multiplying in this case is changing. Lavya, it is not permanent. According to the questions, yes, you can take any variable. If you want, you can write like this also. 2x plus 1. That is also correct. If you want, you can write as 2p plus 1. So these all are correct because variable can be any alphabet. That is not a problem. Okay. There can be 26 variables. Then you can have symbols also, alpha, beta, gamma, theta, beta, zeta, whatever you want. You can put for the variable, no issue. So here what we are doing is we are trying to understand the pattern. Okay, give some more examples. Let's take this one, 1, 4, 9, 10, 25, 36. Okay, let's try this one. What is this? 1, 4, 9, 16, 25, 36, and so on. Class, now tell me what sort of pattern are you finding in this? I know, Bunny, you don't know beta and gamma. You will soon know about all these things also. In physics, science also you will study. These are some special symbols that we use in the physics for the parameters. Now tell me, class, what is the pattern over here? Lavya, for the last example, general formula is this one only, 2n plus 1. Class, please tell me what is the general formula for this example. Ekta is saying it is odd number jumps. Okay. Others, please try. Okay, tell me one thing. What is the seventh term? Tell me the seventh term. Tell me the seventh term of this expression. Please tell me in this series what should be the seventh term. Very good, Avas. No, no, no. Okay, at 13. Very good, very good. Ekta, you got that. Fine. Alan, no. Alan, wrong. Karnik is saying n plus 4. I think Karnik, it will not work. 13 in the last one, add. Okay, very good. So I mean, I think, okay. See, one series is very easy. According to me, not getting the formula, let me give you. Can I say this one came from 1 square plus, can I say this thing? It all depends on the observation. It all depends on the observation. Any sort of pattern can be there. Can I say this 4 came from 2 square? Can I say this came from 3 square, 4 square, 5 square, 6 square? That means this is 7 square 49. Now my pattern is done. I can say the formula or the general formula is simple n square. You can see only term was variable. No constant term is there. That is why it became as n square. I hope it is clear to everyone. You will find very interesting. You just need to understand the pattern. Kritika, it all depends on your practice. The more you practice, the more easily you will be able to understand the general formula. Okay, it is all about practice, nothing else. Yes, class. Everyone, is it fine? Any doubts? Sir, I am very near. Okay, very good. Okay, give some more. Let's see. But in NCERT only we have many examples that we can understand. I think this also we can try. Okay. Suppose we have a pattern. Tell me what should be the general formula in this case. This is very easy. Just to check your understanding. What is the general formula in this case? Very good. Karthik, very close. Tell me the answer. What is the general formula in this case? What formula will you give? Okay, Karnik, 4n plus 1. Let us check whether it is correct or not. When you put n equal to 1, you will get 4 into 1 plus 1 is equal to 5. Very good. But Karnik, as soon as you put n equal to 2, you will get 8 plus 1 as 9, which is wrong. So your formula is wrong. Bani, correct. Karthik, 5n plus 1, wrong. The correct answer is only 5n, because this simple table of 5 multiples of 5, I can write this 5 is actually 5 into 1, this is 5 into 2, this is 5 into 3, this is 5 into 4. So this first term is constant 5, and 1, 2, 3, 4 is the variable. Hence the formula is 5 into n, or 5 into x, 5 into y, whatever you want to say, you can say. I hope clear to everyone. Okay. Now they want us to see the pattern in geometry. Plus the next example is they want us to find a pattern in geometry. So let's try that also. In this case, how many diagonals are there? Please tell me. I think diagonals only they are working on. No? Yes. What is the number of diagonals we can draw from one vertex of a quadrilateral? Okay, this is the thing they want to ask. They want to find a pattern in geometry. The question they are asking is, what is the number of diagonals we can draw from one vertex of a quadrilateral? So you can see, if it is a quadrilateral, from one vertex you can draw only, class please tell me, if it is a quadrilateral, how many diagonals you can draw? Only one. If it is a pentagon, how many diagonals you can draw? Using a vertex, you can draw two diagonals. If it is a hexagon, how many you can draw? You can draw three. So you need to find a relation in this also. You need to understand if the relation of diagonals is coming out as this one. Diagonals is coming out as 1, 2 and 3. 1, 2, 3. And what we have found is this was in quadrilateral, this was in pentagon, this was in hexagon. Can you tell me how many diagonals will be there in heptagon? Sorry, in 7 is hepta only, no? Yes, heptagon. Yes, yes. Just tell me this answer. This is the last one. Try to observe. It is very simple. In quadrilateral, we had four sides. In quadrilateral, we had four sides. In pentagon, we had five sides. In hexagon, we had six sides. So we are doing is 4 minus 1. Okay, then this will be 4. And this will be, oh, okay, do one thing. Time is less today. Tomorrow we will discuss it one more time. Okay, let me close this right now. Stop recording.